Hey everybody, welcome back. We are still going on that theme of quadratics, and the last lesson we learned about graphing quadratics. Now we're going to review / learn about solving quadratic equations. We are still in chapter 0, and we're reviewing this from Algebra 1 or 2. There are 4 ways to solve a quadratic equation. These are the algebraic methods, and then of course you can always solve it by graphing and looking at the x-intercepts. But if it says to solve it algebraically, or if you don't have a graphing calculator, or you don't want to graph it, because by hand graphing isn't always perfect for finding x-intercepts, you can use these 4 methods. I would look at using them in this order. First, always check if factoring is going to be easy. That's going to be really easy if the c value is 0 in standard form, or if the factors are easily determined. You're going to use the square root property if the b value is 0 in standard form, or if it's already in vertex form. You're going to use complete the square if it's in standard form with an even value for b and an a value of 1. And the last method that is always going to work for any quadratic, no matter what the a, b, or c value is quadratic formula. It's not always the easiest, but it'll work. Let's look at some examples together. We have solve x squared minus 8x plus 12 equals 0 by factoring. Notice now we have an equals 0. It's not like y equals. We're actually solving an equation here. And on this problem, it's telling you to use factoring. I won't always tell you what method to use. We'll get to some of those later where you have to pick which method is best and justify why it's the best method. But for now, I'm going to tell you what method to use. This is by factoring, and we'll check the answer graphically with our calculator. So first, in order to factor, I see that this is in standard form already. And I notice that the a value is equal to 1, and it has 3 terms. So when I go to factor this, I'm going to use the a times c method. My ac value is 12. My b value is negative 8. So I'm trying to think of what can multiply up to 12 that adds up to 8. Or sorry, to negative 8. That's going to be negative 6 and negative 2. Since my a value is 1, I can use the shortcut where I know that those two values, negative 6 and negative 2, are the two numbers in the factors. And then I can use my zero product property to split this apart into 2 separate equations, because I know that if 2 factors multiply up to equal 0, then I know that's either 0 times 0 equals 0, or it's 0 times a number equals 0, or it's another number times 0 equals 0. So what I'm basically doing is I'm saying, okay, these factors each split apart and equals 0, because I know it could be 0 times 0. Alright, so now I solve each of these by using inverse operations. They're both linear equations, so they're pretty easy to solve. I'm just going to add 6 or add 2 and get my answers x equals 6 and x equals 2. Now to check that, I need to graph this related parabola in my calculator. So in order to graph that, you're going to turn on your calculator, click y equals, go ahead and plug in, use the xt theta n for your variable, square it, minus 8x plus 12. Be careful here. Remember, the minus sign and the negative sign are not the same, so make sure you're using the minus sign there. It's minus 8x. And then your graph is probably already in standard, like a zoom, but if you want, you can go ahead and click zoom. 6 is standard. And you'll notice that the graph crosses the x-axis at 2 and 6. So that's exactly what we got. In a standard view, those little tick marks, it's a scale of 1, so each one represents 1 unit. So it's really easy to see. That's crossing at 2, that's crossing at 6. We got our answers correct. We're going to do another problem that is solving with the square root property. Keep in mind that you always have to use plus or minus when you square root both sides of an equation, since x squared could mean that x equals positive 2, 2 squared is 4, or it could mean that x equaled negative 2 because negative 2 squared is also equal to 4. Square root property is really great when something's in vertex form like this, so x minus h squared plus k. What you're going to do is you're going to get the perfect square, x minus 2 squared by itself, by moving the k value to the other side, if there is one. And then you can square root both sides of this equation. When you square root a perfect square, it cancels out the perfect square. And then when you square root the other side, you have to remember to put plus or minus in front of it. If you want to do that in a different color up here as well, you can. And then to get our x value by itself, you're going to have to add 2 over to the other side. We usually put that as the first term. So we have 2 plus or minus the square root of negative 12. And your last step is to simplify the root. So let's think about this. We have to simplify negative 12. Anytime it's a negative, you're going to take out that negative 1 first as a factor. Then you can factor down your 12 into 4 times 3. 4 is a perfect square. It's 2 times 2. I know the square root of negative 1 is going to give me I. And then the square root of 2 squared is going to cancel out and just give me 2. I'm going to put that in front of the I. And then I still have this factor of 3 remaining. It cannot cancel out of the root. It has to stay under the root because it's not a perfect square. And then I'm going to bring down my plus or minus, my 2, and my x equals. So I have 2 plus or minus 2i radical 3 as my final answer. Those roots are not going to be able to be checked on a graph. If I did graph it, I'll show you in a second. But if I did graph it, these are imaginary roots, so they're not going to show up as x-intercepts. I'll show you here. So I went back to my y equals screen, typed in the equation of the parabola. And when I first hit graph here, I don't see anything. That's because I'm still in standard view. Remember, standard view only goes negative 10 to 10 on both the x and y axis. But I can tell from this related equation that my vertex is at 212. 212 is above a y value of 10, so I'm going to need to change this window. My highest y value right now on a standard view is 10. Let's go ahead and make that a y max of 20 instead of 10 because I need to at least see 12. There we go. Now I can see my parabola. And notice it doesn't cross the x-axis at all. That's because the roots are imaginary. Next, we're going to work on completing the square. For this method, you always move the constant to the other side and make the a value 1. That's why this is easy if the a value is already 1. I would not mess with completing the square unless the a value is 1. It can get really messy with fractions otherwise. In the margin, you're going to use the formula to complete the square. That formula is b divided by 2, that quantity squared. Whatever you get, you add that result on both sides of the equation, and now you can factor the quadratic side as a perfect square. Let's take a look at an example. If we're solving x squared minus 4x plus 1 equals 0 by completing the square, we'll first move the constant to the other side. We'll go over to the side and use our formula for complete the square. In this, the b value is negative 4. So we simplify that to negative 2 squared equals 4. I would actually write out that extra step there where you have the negative 2 squared. Don't just skip and do that in your head. And the reason why is going to come up in a minute. Take that value that you got, 4, add it to both sides of the equation. You have to do it on both sides of the equal sign to keep the equation balanced. And now it says, now you can factor that quadratic side, that's the left side in this case, as a perfect square. That is because our a times c is 4, our b value is -4. So what can multiply up to 4 that adds up to -4? It's -2 and -2. So since it's the same factor twice, I'm not going to put x minus 2 squared. Alright, I'm not going to put x minus 2, x minus 2. I'm just going to put x minus 2 squared. It's a perfect square. It will always be a perfect square because you completed the square. On the right side, you can go ahead and combine like terms. -1 and 4 makes 3. And now it becomes an example, a problem just like the last example, where we are just going to square root both sides, put the plus or minus on the real number side here. The square root and squared cancel out, so we're just left with x minus 2 on the left side. On the right side, we have plus or minus the square root of 3. It's a positive number, so we don't have to worry about I. And 3 doesn't have any factors that are perfect squares besides 1. That's not going to do anything. So we'll just leave it. We don't have to simplify it at all. But we do still need to get the x by itself. Anytime the problem says solve, your final answer should be in the form x equals and then whatever. So our final answers here will be x equals 2 plus or minus the square root of 3. You can leave the answer like that. Or if you're ever required to break that up, it's the same thing as saying 2 plus square root of 3, 2 minus square root of 3. Well, x equals 2 minus square root of 3. All right. Next, we're going to try quadratic formula. This is example 6 from your book. Here's the formula. Hopefully everybody knows it. If you want, you can go back and review. I'm sure there's YouTube videos of the song about quadratic formula to the tune of Pop Goes the Weasel. You can look that up if you'd like. Otherwise, you might already just have it memorized by now. You've been through a lot of math classes with it. So let's apply it to this problem. You need your a value 1, your b value -4, your c value 15, and you are going to plug those into the formula. It's -b, so negative times -4, plus or minus the square root of b squared. Make sure you put that in parentheses. Minus 4ac over 2 times a. Simplified. Negative times a negative makes a positive. A negative number squared gives you a positive number. Be careful if you're doing that on your calculator. Like I said earlier in this chapter, you're not going to have a calculator on your Chapter 0 test, but just for future reference and on your homework if you are checking with your calculator or anything, when you type this in parentheses, it's correct. It gives you positive 16, which we know it should be positive 16 because a negative times a negative makes a positive. But if you type it in without parentheses, your calculator is going to do the exponent first and then put the negative on the front, which will say -16. That's not correct. So just keep in mind, if you're putting it in your calculator, use parentheses. Now we have -4 times 1 is -4, times positive 15 is going to be -60. And then in your denominator, 2 times 1 is 2. Okay, let me erase that a little bit. Simplify inside your radical. 16 minus 60. It's going to be a negative. It's -44. And then in the denominator, we still have our 2. We do need to simplify this radical. It's negative, so we know there's going to be an imaginary number here. Let's go ahead and take out the -1 on our factor tree first. Take out the 4. 4 times 11 makes 44. 11 is a prime number, but 4 is a perfect square. It's 2 times 2. I know that the square root of -1 is I. I know that the square root of 2 squared is 2. And then the square root of 11 can't simplify. Bring down your 4 plus or minus over 2. Now notice that all of your terms here, you have 3 terms in this. You have a 4, you have a 2i square root of 11, and you have a 2. All 3 of those terms have a common factor of 2. So you need to divide all of your terms by 2 4 divided by 2 makes 2. 2 divided by 2 makes 1. 2 divided by 2 makes 1. You don't need to write over 1. You also don't need to write 1i. This is just going to look like 2 plus or minus I square root of 11. Multiplying or dividing by 1 doesn't change anything. That's why you don't need to write those two. And that's your final answer. All right, now for the practice problems on the next page, it says decide the best method for solving each one and then solve the equation. Like I said before, I would like you to work in order from factoring down to quadratic formula as the last resort and decide what's the best method and then solve it from there. But no matter what method you use, you should get the same answers. So on the chapter 0 test or assessment, there is going to be a question that asks you to use the best method and explain why it's the best method. So I would go ahead and practice that, but keep in mind, no matter what, you're going to get the same answers no matter what method you use. So when you have that question on the test, even if you don't choose the best method, that might be a point off. However, getting the answers right is also worth a lot of the credit. So even if you can't use the best method, don't give up, still solve the problems. Here are the answers for those problems. I'll kind of zoom in on a couple at a time so you can pause and check. Here's numbers 1 and 2. Here's number 3 and 4. Here's 5 and 6. And finally, here are 7 and 8. Okay, that was a lot of practice with solving quadratic equations, or in other words, equations that have x squared in them. You're going to get a lot more practice with these in the homework, so hopefully if you have any questions, that'll kind of help you work that out, and you're always welcome to ask me questions, of course. I look forward to seeing you again soon. Bye, guys!